Hi, in this video we will discuss the third objective of section 2.8. We will determine the validity of a syllogism. We will do so through the last example for this section, which is not quite so straightforward. Let me show you what I mean. So in previous videos we covered this content and talked about these examples. In this video, we will pick up with example 4. So completing a syllogism with a conclusion. So what if I give you a set of premises and ask you to identify the conclusion that creates a valid syllogism? Now maybe you can see what I mean, but not quite so straightforward. So what if you have these set of premises? Some adult bikes have drop handlebars. All drop handlebars are aerodynamic. So again, that means that both of these premises must be true. And we want to identify the conclusion that also has to always be true whenever these premises are true, right? So 4 conclusions. Some adult bicycles are not aerodynamic. All adult bicycles are aerodynamic. Some adult bicycles are aerodynamic. Or some drop handlebars are not aerodynamic. Which conclusion makes a valid syllogism? So I have this written out for you here. For the conclusion to make a valid syllogism, the conclusion must be true whenever all the premises are true. So we'll start this by drawing an Euler diagram for our premises and kind of seeing which conclusions we can rule out. Okay, so let's draw an Euler diagram where the premises are true. I'm going to abbreviate here just for ease. Let's call AB the set of adult bikes. What else do we have? Drop handlebars. Maybe let's call that drop handlebars, DH for drop handlebars. And then we also have aerodynamic. Let's just call that maybe A for aerodynamic. All right, now let's draw our Euler diagram. So some adult bikes have drop handlebars. That means that your adult bikes circle and your drop handlebars circle must have some overlap, right? These are the adult bikes with drop handlebars. Further, it needs to be true that all drop handlebars are aerodynamic. So that means your drop handlebar circle must be completely inside this aerodynamic circle. So now from here, let's investigate which conclusions we can rule out. Again, if the conclusion's going to make a valid syllogism, the conclusion must be true in this picture. So we're looking for which conclusions aren't true, right? We're kind of ruling them out. So let's look at number 2. All adult bicycles are aerodynamic. Well, number 2 is false in this picture. Because what about these bikes over here? These adult bikes are not aerodynamic in this picture, right? So conclusion 2 is false. Well, let's investigate them all while we're at it. So let's investigate conclusion 1. Some adult bicycles are not aerodynamic. That is true. That's these over here, right, are the adult bicycles that are not aerodynamic. So 1 stays for now. 1 could be the valid conclusion. Same with number 3. Some adult bicycles are aerodynamic. Well, that's these guys over here. Let me shade them in a different color. That's these guys over here, right, are the adult bicycles that are aerodynamic. So 3 stays for now. 3 is still a valid, a true conclusion. Number 4, some drop handlebars are not aerodynamic. Number 4 is false. Well, because it has to be the case that all drop handlebars are aerodynamic, right? So 4 is always false. 4 kind of contradicts your second premise here. Okay, so I have this written down for you, that thus far we can say conclusion 2 and 4 are false. So this diagram shows conclusion 2 is false. It doesn't have to be that all adult bikes are aerodynamic, right? The ones that are shaded blue here are not aerodynamic. Conclusion 4 is false, since it has to be that all adult bikes are aerodynamic. Okay, so now we kind of have to decide between conclusion 1 and conclusion 3. And for this, we'll have to draw a second Euler diagram. So it'll start off the same with adult bikes and drop handlebars having some overlap. But let's consider all the different things that could happen with this aerodynamic. All I said, what needs to be true, right, is that all drop handlebars are aerodynamic. But what if your aerodynamic circle looked like this? So now it is still the case that all adult bikes, that all drop handlebars are aerodynamic. But all adult bikes could be aerodynamic too. I didn't say. All I said is that all of these drop handlebars have to be inside the aerodynamic circle. So your Euler diagram could look like this. And in this diagram, both premises are still true. So what about this diagram? This shows, let's look at numbers 1 and 3. Some adult bicycles are not aerodynamic. Some adult bicycles are not aerodynamic. Well, in this picture, 1. In this picture, 1 is false. Because in this picture, all adult bicycles are aerodynamic. And that could happen, given your two premises, right? So since conclusion 1 is false, that leaves us with conclusion 3. So thus conclusion 3 is the conclusion that makes this a valid syllogism. Now let's just check, is conclusion 3 true in this picture? Some adult bicycles are aerodynamic. It is true in this picture. It happens to be that all adult bicycles are aerodynamic, right? But some of them are, for sure. Further, we can say that it's always going to be the adult bikes with drop handlebars that are aerodynamic, right? It's always going to be these ones in here that are aerodynamic, for sure. Okay, so conclusion 3 is the conclusion that makes this a valid syllogism. This completes this example.